Alright folks, so for this video I'm going to be going through several of the optional problems in 3.2.2. All these are going to be using universal elimination and universal introduction. So let's start with A. So A has for the first premise all of x, fx arrow gx. Premise 2, universal x, gx arrow not hx. Since these are both universal claims, we're going to be able to use UE on both of them, and we don't have to worry about doing EE first because there is no EE. So let's go ahead and get our UEs out of the way. So our goal here is universal x, fx arrow not hx. So you could end up doing a conditional proof, because you know that you'll start off with fa arrow not ha. You can do a conditional proof, assume fa, get to negation ha, and then do ui. But I'm not going to, because that's time and I'm lazy. So instead I'm just going to use hypothetical syllogism to go fa arrow not ha from lines 3, 4, hs. And then I'm just going to use UE on line 5. And that actually finishes out the entire proof for that one. It was rather fast and quick and short to the point, which is nice. So let's go ahead and go along to B. So B also starts off with two universals. So we're going to do the same thing we did last time. We're going to go ahead and do UE on both of these just to get rid of those quantifiers. Remember, if there's a quantifier over here, it's the main operator. We can't do modus ponens or modus tollens. There are some exceptions if we had something like this. Then we'd be able to do a modus ponens or a modus tollens since the arrow is the main operator. But notice here, we have two universal statements on the sides of the arrows. Here, the arrow is within the scope of a universal claim. So back to doing UE. We're just going to use A again because A is easy to remember. And then for 5, there's a few ways you could do this. You could, again, do a conditional proof strategy. I'm not going to. Instead, I'm going to use contraposition to actually change the direction of 4. So I'm going to change it to not GA arrow, not HA, from 4, SI9, also known as contraposition. Why? Because then I have another hypothetical syllogism set up. So then I can get FA arrow, not HA, from 3 and 5 hypothetical syllogism. And then from line 6, using UI, I can add back in the universal. So I'm allowed to move from having little a's here to a universal claim, since when I look at these assumption numbers over here, neither of these lines here have an A anywhere inside of here. Since there's no A there, it means that I'm not moving from some particular to a universal about the particular. I'm moving from a universal to a universal, and that'll be important to know later on. Let's go ahead and move on to C. C, again, only has universals. So we're going to start off with UE in both cases again. And then for 4, I'm actually going to change the direction of 4 using contraposition. That's going to be SI9. The reason for doing that is right now I have something that looks like this. A, B, C, not B. And my goal is to get to A, arrow, not C. And contraposition allows me to change this into B, arrow, not C. And then since the B's match, I'm able to use hypothetical syllogism to go from A to negation C. And then from there on line 6, I'm going to use hypothetical syllogism to go FA, arrow, not HA. That's going to be for lines 3, 5, hypothetical syllogism. Then on line 7, I'm going to use UI. That's everything that we had to do for C. Again, you also could have done this as a conditional proof. If you had done it as a conditional proof, then on line 5, you would have written down FA, assumed for the sake of CP in order to reach negation HA. And then you would have been able to do a modus ponens, a double negation. So there's the modus ponens, double negation, modus tollens, and then closed out the conditional proof. But that's a little bit longer. Let's go on to D. D, again, is all universals. So let's go ahead and do UE on both of these. And then we're going to go ahead and do a hypothetical syllogism. But notice our order is a little bit different than what we've had in the past. Right now we have HA arrow negation FA. That's from 3 and 4 hypothetical syllogism. And then we're going to use contraposition on 5 to turn this into FA arrow not HA. And then we get to use UI on that. And then for this one, you also could have done this with a conditional proof. With the conditional proof, what you would have done is you would have assumed FA, and then you would have done double negation FA to get not GA, to get not HA. Because that would have been through modus tollens, that would have been through modus tollens, then you close out the conditional proof. So this is also, again, a little bit longer and why I decided not to do it this way. Let's quickly do E and F. So for E, again, everything here is a universal. In this case, it's only one universal. Notice our goal this time, though, is a little bit different. The main operator here is the arrow, and it's connecting two universal claims. So my recommendation here would be go ahead and do the following. So let's start with doing actually, let's just go ahead and start with the conditional proof. So the conditional proof part of this is going to be, we're going to assume all of the left side here. So we're going to assume x fx. And then we're going to use UE. There we will get GA, and then we can turn that into universal x gx. That came from 3, 4 MPP. That's 5 UI. Now, let's take a quick look at this line because we use UI. In order to assess whether or not we can use UI, we take a look at these assumption lines over here, 1 and 2, and we ask, is there a little a? We don't see a little a in either of these assumption numbers, so we are good to go for using UI. And now we can also close out our conditional proof, because we've proven that given universal x fx, we are able to reach universal x gx. 2, 6, conditional proof. And then we write down the 1 and the 2, and we discharge the 2. Last is f. And as before, everything is universals. Then we're going to do a modus tollens to get not FA or GA from 3, 4 MTT. Then from here we can do a De Morgan's to get not FA and not GA. And from there we can go ahead and pull out the not FA from 6 and elimination. You could also pull out the not GA, but we don't need it. Then for 8, we can just make this into a universal statement using UI. So let's check on the UI. So let's take a look at assumption numbers 1 and 2 and ask, is there a little a? And the answer is no, in which case we are good to use UI. So this was a rather quick look at those 6 problems, but your homework is going to be asking you to do the same thing. We're only going to have universal problems for this part of this problem set. If you actually, I don't even know if you have any problems from this, but I think that your translation problem with the Dalmatian is going to look something somewhat like this.